This is the homework video for the handout for 5/19/18. That is a Thursday. The first question, which starts on number 10, asks which of the following properties are true about a figure that has been rotated 90 degrees. Check all that apply. That is very important. And up here you can see this is my little attempted drawing of a 90-degree rotation. It is not measured, it is not perfect. This is just to represent it. So the first one is the slopes of corresponding segments are opposite reciprocals. That is true. We'll get into that a little bit later in this video. But as you can see in my little rough sketch, each of these 4 quadrants is a 90-degree angle. And when something is rotated 90 degrees or changed 90 degrees, it becomes opposite.
Oh no, I'm just here to show
The second question asks, segments connecting corresponding vertices of the image and pre-image are the same length. This is not true. Let's take this top point up here. It would be, and this pink line represents the distance. You can see that this definitely has distance in between, but this point that was on the center of rotation does not change at all. This is because all points remain the same distance away from the origin, so depending how far away from the origin or center of rotation they were, that changes how far apart they are afterwards. Segments connecting corresponding vertices of the image and pre-image are parallel. This is not true. Once again, you can see my line here. It is definitely not parallel to this line here. And once again, there is no change here. Lines that are parallel in the pre-image are not necessarily parallel in the image. This is definitely not true. One thing about a rotation is that the shape remains the same, all angles and all sides remain the same. So if all angles remain the same, how the sides are to each other would remain the same. So if something was parallel in the previous image, it would have to be parallel in the after image, or the image and pre-image. Corresponding segments are perpendicular. This is true. So let's take this segment here, let's call this B. This would be, well, this would be B prime and that would be B. You can't really tell from my sloppy drawing, but up here, as we said, the slopes of corresponding segments are opposite reciprocals. When something is an opposite reciprocal, it becomes perpendicular because they are entirely opposite. The last question on this problem is corresponding vertices lie on the same circle. This is true. How you rotate something is it's like one big circle around the origin, which is our center of rotation. So the circle would have a radius of the origin to B. And then we simply rotate the point 90 degrees around this circle to get the next one. We do this for all of them, so the pre-image and the image would lie on the same circle. They also remain the same distance away from the origin at all times. 11 asks, in a 90-degree rotation, what happens to the slopes of the corresponding segments of the image and pre-image? How does the coordinate rule show this? In a 180-degree rotation, what happens to the slope of the corresponding segments of the image and pre-image? How does the coordinate rule show this? So over here we have the 90-degree rotation. In the previous problem, which was 10, we stated that the 2 segments are opposite reciprocals of each other, which means they're perpendicular. The coordinate rule shows these things by the coordinate rule for a 90-degree rotation is x, y rotates to y equals negative x. Since the y and the x are switched, that means that they are reciprocals of the previous. And since the x is negative, that means that it is negative or opposite, which means it's an opposite reciprocal. For a 180-degree rotation, the slope remains the same, but the orientation of the points when looking at it on a flat plane is reversed. So if it had been, like on the previous paper, if it had been LM, after it was rotated 180 degrees, it would then be ML. Because M remains the closest to the origin. For the coordinate rule, it is x comma y to negative x comma negative y. That's supposed to be a negative. Since both are negative, when we go to do the change in y or the change in x, the two negatives cancel out, meaning the slope remains the same. The last question asks, well, question 12 asks, in your own words, describe what it means for two figures to be congruent. Remember, this is in your own words, so these are just some of the things that could have been mentioned. So when two figures are congruent, all the angles stay the same between the image and the pre-image. All the sides stay the same within the pre-image and the image. And the image can be flipped in any direction, but as long as all sides, angles, area, perimeter, etc., all measurements stay the same, they are congruent. And that's it. Thank you.